Section 6.6 is on geometric sequences. For your learning targets, you will be able to identify geometric sequences, you will be able to extend and graph geometric sequences, and you will be able to write a geometric sequence as a function. So in geometric sequences, you are multiplying by the same term each time, and what you're multiplying by is called a common ratio. So that's what you're looking for to develop your pattern of a geometric sequence. To write the equation of the geometric sequence, you have another a sub n equation where a sub n equals a sub 1, which is your first term, and then times r, which is your common ratio, to the n minus 1 power. So you're just plugging in your first term and your common ratio, and then that's it. Example 1 is identifying geometric sequences. So we want to determine if these sequences are arithmetic, geometric, or neither, and then explain our reasoning. So looking at the first sequence, we're looking at what the pattern is to get us from 8 to 24, from 24 to 72, and from 72 to 216. And this pattern here is that we're multiplying by 3. So since we're multiplying by the same term, this is our common ratio, this is a geometric sequence. And this is because the common ratio is 3. So anytime that you're multiplying by the same amount, that's called the common ratio. So now looking at the next problem, we want to figure out what pattern we're using to get from 8 to 3, 3 to -2, and -2 to 7. So this pattern is that we're subtracting 5. So since we're subtracting, this is arithmetic. And again, this is an arithmetic sequence because this is called the common difference. Is -5. So we did talk about arithmetic sequences a couple chapters ago. So your arithmetic sequence is when you're adding or subtracting. Again, geometric is when you're multiplying or dividing, but we always want to write it in terms of what we're multiplying by. Example 2 is extending geometric sequences, and we're going to write the next 3 terms. So first we need to determine the pattern. How are we getting from 972 to 324, 324 to 108, 108 to 36? So the pattern, you may notice, is dividing by 3, but we always want this in terms of what we're multiplying by. So dividing by 3 is the same as multiplying by 1/3. So to find our next term, we're going to do 36 times 1/3, which is going to give us 12. Then we're going to do 12 times 1/3 to get our next term, which is 4. And then finally, our last term is going to be 4 times 1/3, which is going to give us 4/3. And you can leave that as an improper fraction. So our next 3 terms are 12, 4, and 4/3. Next one over here, we need to figure out how we are developing this pattern. And in this one, we are multiplying by -2. So to find our next term, we need to do -56 times -2. So a negative times a negative is going to give us a positive. And then 56 times 2 is 112. So now we're going to do 112 times -2. So we have a positive times a negative, so our answer is going to be negative, and then 112 times 2 is 224. And then finally, we're going to do -224 times -2, And again, a negative times a negative is a positive. And then 224 times 2 is 448. So our next three terms here are 112, negative 224, and positive 448. Example 3 is graphing a geometric sequence. And so to start this, it's very similar to what we were doing when we were graphing our arithmetic sequences. So the position is your x, and then the term in the sequence is your y. So our first term is 6, our second term is 12, our third term is 24, our fourth term is 48, and our fifth term is 96. So here are our points. I used a scale of 10 on the y-axis and then 1 on the x-axis. So here's 1, 6, 2, 12, 3, 24, 448, and 596. And again, when you're graphing sequences, you do not connect the points. And you should notice that this is similar to an exponential. So our geometric sequences are similar to our exponential functions, just like our arithmetic sequences are similar to our linear functions. Example 4 is finding the nth term of a geometric sequence. So this is where we're using that equation. So it says write an equation for the nth term of the geometric sequence and then find a sub 10. So there's going to be two different answers here. So our formula for the equation is a sub n equals a sub 1 times r to the n minus 1 power. So we need to find our first term. Our first term here is 3. So we have a sub n equals 3. And then now we need to find out what our r is. What are we multiplying by to generate this pattern? So to get from 3 to 12, we multiply by 4. 12 times 4 is 48. 48 times 4 is 192. So our common ratio here is 4. So once we plug everything in, we don't have to simplify this equation like we did the arithmetic sequences. So this is our answer here. So for the next one, we would like to find a sub 10. So that means that we're going to plug in 10 for n. So I have a sub 10 is equal to 3 times 4 to the 10 minus 1 power. So now we're going to do, start with simplifying this exponent. So we have 3 times 4 to the 9th power. So now that we have that simplified, we want to do 4 to the 9th power first. 4 to the 9th power is 262,144. And then finally, we want to multiply that number by 3. And we get 786,432. And then I'm going to bring down my a sub 10 right here. And remember, this 10 is staying there because that's telling you that this is the 10th term of that sequence.